All right, let's jump right in. We hear the word vector thrown around all the time, right? From high school physics to a blockbuster movie. But what in the world is a vector really? Well, it turns out the answer is both way simpler and way, way cooler than just an arrow on a page.
So let me just ask you this. If I tell you I'm driving my car at 10 miles per hour, do you have any idea where I'm going to end up? Not really, right? You know how fast I'm going, sure, but you have absolutely no clue which way I'm headed. And that exact problem, that's why vectors were invented.
And this gets to the heart of it. There's a fundamental split in how we describe things. On one side, you've got scalars. These are simple, just a number, things like mass or time. But on the other side, you have vectors. And for these, a number isn't enough. You need the number and a direction. 10 miles per hour, north. Now you know what's happening.
Okay, so with that idea in our heads, let's get a little more official about it. What is the textbook definition of a vector? Here we go. The classic Euclidean vector. This is the one you're probably picturing in your head right now. It's that geometric object, that little arrow that has two essential pieces of information baked right into it, its magnitude and its direction. So let's break those two things down. First up, we've got magnitude. Just think of this as the how much part of the vector. If we're talking about a journey, the magnitude is simply how far you traveled. If it's a force vector, it's how hard you're pushing. It's the raw quantity, the length of the arrow itself. And here is the other crucial half of the equation, direction. This is the which way. It's where that arrow is pointing. It's not just about the distance covered. It's about the specific path you took, the displacement from your starting point A to your ending point B. And this is just perfect. The name itself gives us a huge clue. The Latin word vector literally means carrier. It's the perfect way to think about it. A vector is the exact information you need to carry something from one place to another. So this classic idea, this carrier arrow, is incredibly powerful, especially when you start looking at the physical world around us. Just look at these examples from physics. Displacement isn't just how far you walked. It's the direct line from where you started to where you ended. Velocity, that's a car's speed and the direction it's heading. Acceleration, you better believe a rocket's thrust has a direction. And of course, force. A push or a pull is always going in a certain direction. None of these things make any sense with just a number. They all need a direction. It's why vectors are basically the language of physics. Okay, but here's the twist. This is where the whole idea of a vector gets blown wide open and becomes so much bigger than just a simple arrow. You see, the real genius, the true power of vectors, isn't about what they are, an arrow, but about what they can do. And everything they can do boils down to two beautifully simple rules. These are the two rules to rule them all. First, you can add two vectors together. Think about it. You take one trip and then another trip. The result? A new single vector that takes you from your original starting point to your final destination. And second, you can multiply a vector by a regular number, a scalar, to stretch it out, shrink it down, or even flip it around 180 degrees. And this is the huge conceptual leap. Mathematicians realized that any collection of things, literally anything, that follows these two simple rules of addition and scaling forms something called a vector space. And if something lives in a vector space, well, then you can call it a vector. And there it is. That's the big aha moment. A vector doesn't have to look like an arrow at all. It just has to behave like one. As long as it plays by the rules of addition and scalar multiplication, it's in the club. And that idea, well, that changed everything. So how does this super abstract idea connect to our world today? Well, this is where we get to the really modern stuff. Vectors as pure data. In the world of computers and data science, a vector is often just a list of numbers, a sequence. That's it. This list of numbers might not represent a direction in the physical world, but because you can add these lists together and scale them with numbers, they are mathematically 100% vectors. And this leads to some pretty mind-bending examples of vectors you might never have guessed. For instance, a list of probabilities, like the chance of different outcomes for an election. You can treat that as a vector. It lets data scientists measure the distance between different predictions. Or how about a logical vector, just a string of ones and zeros? That's the bedrock of how computers process information. You can even have vectors made of more complex things like functions or even infinite sequences.
As long as they obey those two simple rules, we can use all the powerful tools of vector math to understand them. The arrow really is just the tip of the iceberg. So let's pull all this together. Why should we care so much about this one concept? What's the big takeaway here?
It's because vectors give us this incredible universal language to describe anything that has both a how much and a which way. And it doesn't matter if that which way is a direction in the real world or a direction through some crazy high-dimensional space of data. The language and the math is exactly the same. And that leaves us with one final thought to chew on. An arrow is just one kind of vector that we use for physical space. But what else in your world, in your job, in your hobbies, in the way you think, isn't just a quantity, but a quantity with a direction? I bet if you start looking, you'll find that vectors are absolutely everywhere.